Okay, so this is part 4 of our Unit 1 videos, and we are going to be looking at multiplying polynomials, and then we're going to look at factoring them. And these are kind of the opposite directions of working with polynomials. So multiplying them out, we will have something like this, where we are multiplying them and it becomes just a bunch of terms added together. And when we factor, we're going the opposite direction. So we'll have something like that, and we'll want to write it into something like this. Now, there are some terms we kind of want to go over first. So first off, our kind of most basic types of polynomials are a monomial. That means it's just one term. So that would be something like 2x cubed, something like that. A binomial has two terms, so that would be something like x squared plus 3x. And a trinomial would be something with three terms, so something like maybe 3x squared plus 2x minus 7, something like that. So three terms. The degree of the polynomial is the highest exponent. So in the examples we just looked at, here the highest exponent is 3, so this would be a degree 3. If we have x squared as our highest exponent, that would be x squared, so degree 2. And same thing here, degree 2. Even if it's not the first term, whatever term is the highest. So let's say, for example, this instead of 3x was 3x to the fourth power. Then the degree of this polynomial would be 4, even though it's not the first term. This is the general definition of a polynomial here, and oftentimes students are really intimidated by this big long formula here. It's not a formula you're using to plug anything in. It's actually not a formula at all. It's a definition. This is the general form of any polynomial. This is the largest term, the term with the largest exponent. That tells us the degree. And this is what's called the leading coefficient. It's the number in front of the term with the largest exponent. This is the constant on the end, and then these are each subsequent term. So next lowest exponent, all the way down to just a constant. There are some special products here, but truthfully, I don't spend a lot of time going over these with students because you don't need them. You can use them as a shortcut, but really, once you know how to multiply something out like this is really just as easy as using a formula, and you don't have to memorize it. So I personally just prefer multiplying things out. Now, if back in a previous algebra class, maybe algebra 1 or algebra 2 or sometime in high school, you saw teachers teach something called FOIL. If you remember that and you really liked it, feel free to keep foiling. You don't have to use the method that I use. You can use whatever method you like for multiplying these out. And if you like FOIL, feel free to keep foiling. I like using what's called the box method. So the box method I feel like is better because it works with any size polynomial. FOIL can be challenging when you start getting bigger and bigger polynomials you're multiplying out. It's hard to know whether you've covered everything if you multiplied everything out. But the nice thing about the box method is it's impossible to miss a term, and it's organized, and it kind of does some of the work for you. So the box method is really just multiplying these two polynomials, and the size of the box will depend on how many terms you have. So here I have 2 terms, and here I have 3 terms. So I'm going to make a 2 by 3 box. 2 by 3. And I'm going to set up my box with the 2 terms here, 2x plus 2. And over here, my 3 terms, negative 2x squared minus 5x plus 1. And for now, I'm just not worrying about that negative 3. We'll get to that next. So from here, what we're going to do is we're going to multiply the terms that line up with the box. So for example, this first box here is going to be 2x times negative 2x squared. 2 times negative 2 is negative 4. X times x squared is x to the third power. Then for this box, negative 2x squared times 2 is negative 4x squared. 2x times negative 5 is negative 10x squared. And 2 times negative 5x is negative 10x. 2x times 1 is 2x, and 2 times 1 is 2. So that's the multiplying step. The next step is combining like terms. And so I'm going to cross out the terms once I've used them here. So X cubed. There are no other terms with x cubed. So that term has no like terms. I'm just going to bring it over here, and I've used that box, so I'm going to go ahead and cross it out. Here I have two terms of x squared. Negative 10x squareds plus negative 4x squareds is negative 14x squareds. We're counting how many x squareds we have. I've used those two boxes. Here I have negative 10x and a positive 2x. If I have negative 10x's and a positive 2x, that's negative 8x. I've used those boxes. And the 2 doesn't have any like terms, so it just gets brought over. Now the only step we have left is to multiply that negative 3 that we still haven't taken care of. And you could use a box, but it would be a 1 by 4 box. You really don't need to do that. It's just going to get distributed onto each term here. Negative 3 times negative 4 is positive 12x cubed. Negative 3 times negative 14 is positive 42x squared. Negative 3 times negative 8 is positive 24x. And negative 3 times 2 is negative 6. And that's our answer. So again, I like this better than FOIL because if you were going to do FOIL here, you would have to do 2x times 2x squared, 2x times this, 2x times this, and then 2 times this, and 2 times this, and 2 times this. And when these get bigger and bigger, if we had 3 terms times 3 terms, or 3 and 4, it just starts to get really messy. So it's up to you. You can use FOIL or you can use the box method. We're going to do one more, and we actually practiced this at the end of the last video where we were multiplying out things like this when we were rationalizing the denominator. And I said we would take a closer look at how to do that in the next video, and here we are in the next video doing that. Just like the previous example, we have 2 terms and 2 terms. So again, I'm going to make a box. I have 4 minus 2 square root 3. And I have negative 5 plus 7 square root 6. And multiplying those out, negative 5 times 4 is negative 20. Here, when we're multiplying numbers and square roots, the number out front, this does not have a square root, so this is out front, and the number out front get multiplied, and the square root just stays the same. So negative 5 times negative 2 is 10, square root 3. Same here. This does not have a square root attached to it, so the numbers out front get multiplied. 4 times 7 is 28, square root 6. And then here I have the square root of 6 and the square root of 3, and then I have 7 and negative 2. So 7 times negative 2 is negative 14. And the square root of 3 and the square root of 6, 3 times 6 is 18. Now we need to simplify things as much as possible. So let's kind of take this one off to the side real quick. Negative 14 square root 18. 18 is the same thing as 2 times 3 times 3. And like we saw in a previous video, when we are simplifying square roots, we can pull that out and we'd have negative 14 times 3 square root 2 left. Well, 14 times 3 is 42. So that's what this simplifies to, negative 42 square root 2. Now again here, if we have any like radicals, we want to combine them together. But here I have a square root 3, here I have a square root 6, and here I have a square root 2. I don't have any like radicals. So writing out my answer is just listing all of these out, and it doesn't matter the order. And that would be our answer. So that is multiplying polynomials. We are going to switch now to factoring polynomials, which is a little bit harder than multiplying them out. It takes a little bit more thought and effort to try and figure out what were the original factors before it was multiplied out. I'm going to show you a method I like. And similar to what I just said, if you have a method for factoring that you like, you're welcome to keep using it. I'm going to show you what I do, and I feel like it's a really useful method. I will use it all semester long. You really need to have a method for factoring that you're comfortable with and that you've mastered, because in all future math classes, factoring is a skill you're going to need to know. Teachers will assume you can factor something like this. Now, when we're factoring, the number of terms is kind of our signal as to what method we're going to use. If I have 4 terms, what I should be thinking is factoring by grouping. And factoring by grouping is literally grouping terms together and factoring them. So here I have x cubed plus 6x squared minus 2x minus 12. Now, any type of factoring we're doing, whether it's 4 terms, 3 terms, 2 terms, whatever, it doesn't matter. Anytime you're factoring, what you always want to do is pull out the greatest common factor first. So if I'm looking at this polynomial here, excuse me, I want to look at all 4 terms and see if there is a common factor among all 4 terms. Well, looking at this, I can tell you that there's not. Here, there's no numbers. There's no number out front. Now, 6, 2, and 12 all have a common factor of 2, but this term does not have a 2, so there's no common factor among all 4. Now, these 3 terms all have an x, so I could pull out a common factor of an x, except this last term does not have an x. So there's no common factor for me to pull out from all 4 terms. So I've done that. I've done my due diligence of making sure there's no GCF for me to pull out. From there, what you're going to do is you're going to group the first 2 terms together, and then you're going to group the second 2 terms together. And in each of those groups, now we're going to be looking for what's the common factor just in that group. So looking at this first group here, I have x cubed and x squared. I have a common factor of x squared. And what's left is x plus 6. We pulled out 2 of the x's from here, and we pulled out 2 of the x's from here. And then we're left with x plus 6. And you can check if you did this right by distributing it back in. If I were to distribute this x squared back in, then I would have x squared times x would be x cubed. X squared times 6 would be 6x squared. And we're going to do the same thing here. Now the common factor here is 2, and these are both negative, so I can actually pull out a negative 2. And what I would be left with is an x plus 6. 12 divided by 2 is 6. We pulled the negative out from both of them. I can check and see if this is correct by distributing the negative 2 back in, and I have negative 2 times x. Give me negative 2x. Negative 2 times 6 is negative 12. So far, so good. And what we're going to be doing now is if you look at this as a whole term and you look at this as a whole term, they both have a common factor of x plus 6. So we're going to pull that out. And what's left is x squared minus 2. And now it's factored. So my answer is x plus 6, x squared minus 2. And the nice thing about factoring is you can always check your answer. If you wanted to see, am I doing this right? I'm not sure. You could always do the box method, or you could FOIL this really quickly and check and see. And I'll tell you now, if you use the box method or you FOIL this out, you will get back to what we started with. Okay. Now this is the method that I use for factoring trinomials, and you probably have seen in previous math classes some teacher factor something like this, and they oftentimes will use something that looks like this. Some teachers call it a diamond problem, some teachers call it an X method, and unfortunately all of these methods look really similar, but they're all a little bit different. So if you are very comfortable doing things like this and factoring this, and you are like, I know how to do this, I don't need to learn another method, great. Keep doing it the way you've been doing it. That's perfectly fine as long as I'm seeing the method you're using. But if you're like, I've learned a lot of different methods, I'm not really sure, I don't really remember, then this, I think, is a really good option that you should consider in how to factor these kinds of problems. So what we're going to do is, if we are working with something like this, the general form of a trinomial, 3 terms here, is ax squared plus bx plus c. A is the number in front of the x squared, b is the number in front of the x, c is the constant on the end. We are going to take our a value and our c value and put that up top, and we're going to multiply them. And then we're going to take our b value and we're going to put that on the bottom. And what we're looking for are two numbers that when we multiply them, give me this number up here. And when I add them, give me this number down here. So let's do this with the problem we have here. Now, before I start jumping right into this method, anytime I'm factoring, any time at all, I need to make sure I pull out my GCF if I have one. And looking at these three terms, I see that they are all divisible by 2. So before I go into the x method here, the first thing I need to do is pull out that common factor of 2. And when I pull out a 2 from each of these terms, I'm left with 3x squared minus 2x minus 5. This is what's going to be going into the x method. So my a value is 3, my c value is negative 5. 3 times negative 5 is negative 15. My b value is negative 2. And I'm looking for two numbers that when I multiply them give me 15, and when I add them give me 2. Well, first off, if they multiply to a negative number, that means one of these is positive and one of these is negative, because it's not possible to get a negative product if these are both positive or both negative. Now let's think about all the numbers that multiply to 15. 1 times 15 and 3 times 5. No other numbers multiply to 15. Well, I'm looking for numbers that are going to give me a difference of 2, because one's going to be positive and one's going to be negative. So that's going to be 3 and 5. Now it matters which one I say is positive and negative. If I'm adding these numbers together and I say that 5 is positive and 3 is negative, positive 5 and negative 3 give me a positive 2. That's not right. So what I actually need is a negative 5 and a positive 3. Negative 5 plus 3 is negative 2. So from here, so far this probably looks like a method you've seen before. Most students have seen a method kind of like this, but this is where maybe this method is going to take a different turn than what you've seen before. From here, what we're going to be moving into is writing this in factored form. So this is going to go to ax plus those two values, ax plus those values. And at first you're going to think there's too many a's in here, because right now if I multiply these out, I would have a squared, not just a. So my a value is 3. So 3x plus 3 and 3x minus 5. And if at this point I FOILed this out or I used the box method, I would end up with 9x squared, not 3x squared. So I know I have an extra 3 in here somewhere. And I call this step taking out the trash. I know there's an extra 3 that needs to be taken out. It's trash. It should not be in here. It's going to be the 3 where there's a common factor. So 5 and 3 don't have a common factor, but 3 and 3 have a common factor of 3. That's the 3 that should not have been in there. It's not a common factor we're taking out. It should never have been there in the first place. And then I have 3x minus 5. Now it's possible that there's trash in this one, it's possible that there's trash in this one, or it's possible that there's trash in both of them. So you need to make sure you're checking both of them. And then I also need to make sure I don't forget the 2 that we pulled out in the beginning. And if I use the box method or FOIL and I multiply that out, I will in fact get to what I started. Now, in addition to factoring trinomials, so we've gone over if we have 4 terms, we've gone over if we have 3 terms. If we have 2 terms, these formulas you do actually need to know. If you have a squared minus b squared, that is a difference of 2 squares. That'll be a plus b or times a minus b. So a quick example of that would be if you had, let's say, x squared minus 9. Has to be a subtraction sign in the middle. These are both perfect squares. This would be x plus 3 and x minus 3. Now, the sum of 2 cubes and the difference of 2 cubes, that means these are perfect squares here, something we could take the cube root of. And this is the formula if there's a plus sign. This is the formula if it's a negative sign. These 2 formulas look very similar, so here's how you can keep them straight. If it's a plus sign here, it's going to be the same sign, the opposite sign, and a plus sign. So same, opposite, plus. And then the rest of it stays exactly the same. A squared, AB, B squared. Here, if it's a minus sign, it's the same sign, the opposite sign, and then plus. So we are going to use these formulas to do an example here. I have, we want to factor using the formulas above, and we have 81x cubed minus 24y cubed. Now, just like every other problem we've looked at, we always want to make sure that we are taking out the common factor first. So 81 and 24 have a common factor of 3. And we're left with 27x cubed minus 8y to the 6th power. And then I'm trying to figure out what are my a values and my b values. A, in this case, is going to be the cube root of this term, and b will be the cube root of this term. Well, a then is 3x. The cube root of 27 is 3. The cube root of x cubed is x. And then my b value, well, the cube root of 8 is 2, and the cube root of y to the 6th power is y squared. Once I have my a and my b value, it's just determining which formula this goes with. And this is a perfect cubed and subtraction. So I'm using this bottom formula here. Once I have my a and b values, I'm just plugging it into that formula. So a is 3x minus 2y squared. 3x minus 2y squared. And I want to make sure I don't forget that 3 we pulled out in the front, so I'm just going to go ahead and bring that down. And then a squared. 3x squared is 9x squared. And then plus ab, well, plus 3x times 2y squared would be plus 6xy squared. And then plus b squared, well, 2y to the 2nd power squared is going to be plus 4y to the 4th power. And that's it. It's just a matter of using the formula. So those are formulas that you will need to know. Okay. All right, on this last page of this video that we're going to be doing, we're just going to be practicing those methods that we just worked through. So we're just going to be going through some factoring by grouping, some pulling out the greatest common factor, and then factoring other trinomials here. Okay, so let's go ahead and first just practice pulling out the greatest common factor. 16, 8, and 12, they're all even, but they're also all divisible by not just 2, but 4. So I can pull out a common factor of 4. And looking at the variable parts, here I have an x squared, but I don't have any y's. So I know that y won't be part of my common factor. I have 2 x's here, I have 4 x's here, and 4 x's here. So the most I can pull out from all 3 terms is x squared. I can't pull out more than this term has. So pulling out 4x squared, what's left from this first term is just 4. From here, 4 times 2 would give me 8. I pulled out 2 of these x's, but I still have 2 more x's there, and then the y squared. And then minus, and 4 times 3 would give me 12. I pulled out 2 of these x's, so I still have 2 left, and then y to the 5th power. And that is just pulling out the greatest common factor. Now this next one's a little bit harder to see because we have parentheses here, and oftentimes when students see something like this, they immediately think, oh, I need to distribute. No, you don't actually need to distribute in this question. That's the opposite direction of what we want to do here. This term right here and this term right here have a common factor of x minus 3. So I'm going to pull that out, and I have x minus 3. And what I'm left with is 6 plus y. So it's kind of like just the last step of factoring by grouping. All right, now let's practice factoring by grouping. So here we have 4 terms, and again, anytime we're factoring, we always want to pull out the GCF first. 6, 9, 4, and 6. 9 and 6 and 6 have a common factor of 3, and 6 and 6 and 4 have a common factor of 2, but all 4 numbers don't have a number that's in common. Here we just have x's. Here we have x's, they have a common factor of x. Here we have x and y, but there's no variable part that's the same in all of them. So there's no GCF for me to pull out. I can just go straight into factoring by grouping then. And in this first group, 6x squared and 9x have a common factor of 3x. and what's left is 2x minus 3. In this next part, 4 and 6 have a common factor of 2, and both terms have a y, so I can pull a y out. Now, if I just left it like that, and let me do this in pencil here so I can erase it. If I just left it as positive 2y, then what I'd have left with here would be negative 2x plus 3. And that almost looks like this, but the signs are off. It should be a positive 2 and a negative 3. So what I can do instead is rather than just pulling out a 2, I can pull out a negative 2. And if this wasn't negative, I would need a plus sign here. And when I pull out that negative, now the negative's pulled out from the 4, and I'm left with positive 2x. And I pulled a negative out from here, so to make this a positive when I redistribute, that would have to be a negative here, because a negative times a negative would give me that positive, and I'm left with 3. And now, these are the same. So I can go ahead and pull that out, and I'm left with 3x minus 2y. And it's factored. Let's do another one. Again, we want to look for a GCF, but among all 4 terms, there's no variable or no numerical part that's a common factor. So I can go straight into factoring by grouping. In the first group here, 4ab minus 6, we have a common factor of just 2, and I'm left with 2ab minus 3. And in this next group, 3b minus 2ab squared, all I have is a common factor of, there we go, b. There we go. Oops. Whiteout's kind of messed up there a bit, but hopefully you can still read that. So, pulling that out, I'm left with 3 minus, and I'll have 2ab. Now again, these almost look the same, but not quite. So, rather than having this be a positive b, I could pull out a negative b, and I could reorder these. So, if I pull out a negative b instead, I'm just going to, rather than whiting that out, I'm going to write underneath it 2ab minus 3. And rather than pulling out a positive b, let's pull out a negative b. And if I pulled out a negative b from here, then this would be a negative 3 and plus 2ab. And even though these are written in the opposite order, we have the negative on the 3 and the 2ab is positive. Again, I can just switch that order. Those are the same. 2ab minus 3 minus b, and then 2ab minus 3. And now those are the same. So I can pull that out. 2ab minus 3. And I'm left with 2 minus b. And then it's factored. Now let's do some other factoring here. And these might look a little bit more complicated. In fact, I know they look more complicated than the ones that we were just doing, but we can still apply the same method to these. Again, anytime we're factoring, we always want to pull out the greatest common factor first. Looking at these 3 terms here, there's a common factor of z squared, left with z squared minus 12z plus 35. And then I can go ahead and use the x method here. My a value is 1, my c value is 35, 1 times 35 is 35, and the nice thing about when your a value is 1 is there won't be a taking out the trash step. We want 2 numbers that multiply to 35 and add to negative 12, so let's think about what multiplies to 35. 1 times 35 and 5 times 7, those are the only things. Well, negative 5 and negative 7 multiply to positive 35 and add to negative 12. So this is going to be z squared, just carried over, and then z minus 5 and z minus 7. Again, if your a value is 1, there's no taking out the trash step, so that is our answer. Now in the next example, you'll notice that our largest term is negative, and anytime that happens, I strongly suggest, even if there's no greatest common factor, that you pull out a factor of -1. It will make your work a lot easier. Now these numbers do have a common factor. 45, 12, and 12 have a common factor of 3, and all three terms have a y. So I'm actually going to pull out a -3y. And what's left then from the -45y cubed is 15y squared. From the 12y squared, we will have a -4y. And from 12y, we will have a -4. And from there, I can go ahead and use the x method. Now here my a value is not 1, so I will need to be using the taking out the trash step. 15 times -4 is -60. Let me go ahead and zoom in. I know I'm writing kind of small here. And then -4 is my b value. Now 60 has a lot of numbers that multiply to it, so I'm just going to kind of go down the list. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. All of those multiply to 60. And we were looking for two things, since this is negative, that give me a difference of 4, and 6 and 10 do that. -10 and +6. The 10 has to be negative because -10 plus 6 is -4. If it was +10 and -6, this would be a +4. So I have 15y minus 10 and 15y plus 6, and I have that -3y out front. Here we have trash in both of them. 15 and 10 have a common factor of 5. And 15 and 6 have a common factor of 3. So what I'm left with is that -3y out front. 15 divided by 5 is 3y minus 2. And then 15 divided by 3 is 5y plus 2. And if you multiply this out using the box method or FOIL, you will get to what we started. I encourage you to pause the video and actually multiply it out and check and see that that's the case. We have 2 more left. I know this video is getting a little bit long. Hopefully you're hanging in there with me okay. Again, same thing. We always want to check first to see what our greatest common factor is among these 3 terms. And in this case, 24, 76, and 40 have a common factor of 4. Now, let's say you didn't know that right away. Maybe you saw, okay, well, they're even, so at least it's 2. You can start by pulling out a 2, and then you'd see that they're all still even. You could pull out another 2. They also all have a common factor of y, so I'm going to pull that out as well. From the 24, then we have 6x squared minus, and 76 divided by 4 is 19. Again, you could use a calculator if you didn't know what that was. And then plus, and dividing by 4, that'll be 10. Oops, this should be, oh no, that's right. All right. All right, so from here we can go into the x method here, and 6 times 10 is 60, and then -19. And using the previous example, we already multiplied out all the products that give us 60. So we want ones that add up to 19. Well, 4 and 15 add up to 19. They'll both be negative, so that they multiply to a positive and add to a negative. 4y is still out front, and my a value is 6, so 6x minus 4 and 6x minus 15. In this case, there is trash in both of them, so we'll go ahead and take out the trash. 6 and 4 have a common factor of 2. 6 and 15 have a common factor of 3. So we are left with 4y, and 6 divided by 2 is 3x minus 2, and 2x minus 5. One more problem, in this one the variables definitely look more complicated, but the process is still the same. So I still first want to look and see if there's a common factor among all of these terms. 9, 24, and 16 don't have any common factors, but there are common factors of the variable parts. So all 3 terms have an x, all 3 terms have a y. I can pull out xy. And I'm left with 9x squared minus 24xy plus 16y squared. And you'll notice that going this way, I have x squared, x, no x. Going the opposite direction, we have y squared, y, no y. So kind of tying back to a previous example, if this had been x squared, x, no x, and then that we had had a y squared, y, no y, then instead of having it be 6x minus 4 and 6x minus 15, it would be 6x minus 4y and 6x minus 15y. You'd have a y on the second term. And that's what's going to happen here. And again, if you don't believe me, you can multiply them out and check and see. 9 times 16 is 144 and negative 24. And I'll just tell you right now, 12 and 12 multiply to 44, and 12 plus 12 is 24, so negative 12 and negative 12 give us those two numbers. So then I have x, y out front, and I have 9x minus 12y and 9x minus 12y, because again, it's the same number here. Well, these both have trash. They both have common factors of 3. Since they're the same. And I'm left with 3x minus 4y and 3x minus 4y. And again, if you don't believe me, multiply them out using FOIL or the box method and you'll get to where we started. And that will take us to the end of part 4.